Hello and welcome everyone to our latest webinar about our mapping expressions. I'm Peter Schmidt, Customer Success Agent with AX Semantics, and I'm guiding you through our mapping expression today. What is the mapping expression? What can we use it for? We use it to modify data. Modification of data in our system is necessary to correct for spelling errors. We can clean up data values that are incorrect for your applications in the text. We can create new string combination if we have to concatenate a few strings. We can work with lists pretty well in the mapping expressions. We can filter enumerations. We can concatenate lists, and we can sort stuff to bring stuff in another order. We can modify each element of a list to prepare it for the use in your text project. We can do, of course, also calculations, basic arithmetics like adding, subtracting, dividing, multiplying. We can sum up lists. We can calculate quota between stuff. So any kind of modification of the data you upload to our system that is necessary before you can use the data in your output content, you can pretty much do with our mapping expressions. Second chapter, how to use the mapping node. First, a little explanation about what makes up the mapping node. We have a little graph here. So this is the mapping node, and you see it has several things it consists of. First, we have a truth port. This truth port can accept a Boolean value of true or false, and if it gets input a true value, the expression that is happening in mapping 1 or the modification of data that is happening in this mapping node is valid, and we may use it. This is also the default value. If you connect nothing to this trigger, it's thought of as true. It has input ports where you connect the actual input data. This is usually coming from data nodes or from other mapping nodes, and this connects the outside world to this mapping node so that you can use stuff from the outside world in the mapping node and change it. Then, of course, it has an output port where the result of that node is provided to the outside world. Always remember, mapping nodes can accept any number of inputs. So you see 2 input ports in here. It can be any number between 0 and no limits upward, but it only has one output port always, exactly one output port where the result is presented. The data flow goes always from left to right. You might have noticed that in our platform in general. Every graphical element that we have always accepts inputs on the left side and provides outputs on the right side so that they neatly stack right next to each other. We have a preview in that mapping node. It's in the bottom area of this node. It consists of 2 parts. First is the truth value. This is the green dot you see here. This is usually determined by the truth port input. If nothing is connected here, this will always be green, so true. But it also has an area for text, and this gives a preview of the value that is calculated inside this mapping node. And of course, it has a name. This is just for us humans to recognize the node and to search for it. It has no programmatical meaning. The next part of the mapping node is the mapping expression. What is the mapping expression? The mapping expression is the actual code that codifies what a mapping expression should do. It's written in its instruction language. It's our own instruction language. And this expression modifies inputs and provides them at the output where the name to map or the mapping expression comes from. So it's a mapping of inputs to outputs. That's the mapping expression's job. And the scope of this language or of this mapping expression is limited to inside this node. What does that mean? Imagine you have several nodes, several mapping nodes, and each of them has an input which is called param1. This is the default in our platform. Then the mapping expression of this node cannot see the param1s of the other mapping nodes. This is very important. A mapping expression only knows the names of the inputs of its own node. You will see how that works when I go over the practical examples later. And the functions that you can put into a mapping expression support nesting, which means you do not have to write only one function in one mapping node, but you can have as many functions as you like in one mapping node, as long as it only has one result. So you cannot parallelize inside a node, but you can apply several functions on the same data in one and the same node. So let's go to our tool and see how mapping nodes can help you. I prepared an example project with some small example sentences, and let's see how the mapping expression can help us for these tasks here. So the spelling of cheesecake is now corrected. I have data that is not spelled correctly. I want to say hot dog, but I have given hot god in the data set, which of course is a typo. Now I want to correct that typo. How can I do that? We can go to our transform area. And first read in the data, which is called typo in German. You see, we read hot god. Now we want to replace this hot god with the correctly spelled version, which is hot dog, of course. Now what do? I pull a mapping expression or a mapping node next to the data node. And you see it already has the trigger input. It has its output port, but it does not have an input parameter. We have to add that. Click on add parameter. Give it a name or not. I won't today. And I connect this input to the data node. And now the value of this data node is available to me in the mapping 9. So now, for example, I can refer to param1, and you see I have a preview of the value of data 9, still with the error. Now to correct the error, I will use a function which is called replace. I placed it around param1, and you see you get a help you get a tooltip and a help text for this function. So replace raw string, this is the input. Old sub is the stuff we're looking for. New sub is the stuff we want to replace it with. So I just type it out. Replace God in the input by dog. Close the function, and the mistake is corrected. Hot dog. Last thing to do, put a variable here called typo corrected. And for comparison, I put another variable here, which will be called typo in there. And now I can use that here. Place it in the sentence. First, where is it? Typo in there. Hot god. And I place the corrected output here. Hot dog. the spelling of hot god is now corrected, hot dog. So this is how you can, for example, correct spelling errors. The next thing you can do with mapping expressions is concatenating, which means joining words that you get from the data. So you can build composite words, so you can use them in the text, 2 words from the data set, so you can output them. I have 2 words in our uploaded data set. Again, I access them first with data nodes. Let's see how the data looks. So text 1. Okay. Text 1 is my first word. Text 2 is my second word. Now, again, I add a mapping expression, and now just the same as before, I have to add parameters, but this time not only 1, but 2. And then I can connect both inputs to their according data node. And now I have both of these values available in this mapping node, and I can access them. Now to write them next to each other, I can just like add them with plus symbols. So for example, hashtag param1 is the first word, this parameter coming from here. Addition symbol, hashtag param2. And now our machine just writes them next to each other. Second word pan here. And I have the word frying pan made from frying and pan. Same procedure. I add the variables. Word 1, word 2. And now I can put them in here. So frying, our suggestion even found it. Word 1, can just click on create the container. Pan, also add it as a container. And now this one I have to set myself. And I have the concatenated word here, concatenated word to frying pan, and frying and pan are combined to frying pan. Let's see it switch around. Hot and dog are combined to hot dog. Frying and pan are combined to frying pan. We can always do that now. Okay, what's the next step? Next thing we can do with a mapping expression. We can, for example, connect lists, which is pretty much the same thing as we're doing with the string up here, but we now do it on lists so that we can merge 2 lists, write them next to each other. So again, first we look up where the lists are. We have list 1, list 2. Add the data nodes for them. And another one. List. Now lists are concatenated a bit differently from text. but in structure, it's completely the same as this one. I have to add 2 parameters to my mapping node. I connect them to the data nodes, and then I put them together in a list, in a new list. So param1, comma, param2. And now you see we have the first list and a comma, and then the second list inside a bigger list. We can now flatten that to remove the different levels of these lists, the nesting. And we have, as a result, one complete long list. Now, notice the param1 in here of this mapping node is completely spelled the same as the node, as the param1 in here. But the mapping expression exactly knows that I refer to this param1 in here. So a mapping expression only knows the parameters of its own node. That's very important. Okay, same thing. For a list, of course, I have to add a group and a variable so that our system recognizes it as lists. So concatenated list. And here we have list 1 and list 2. And from that, we again can add a container and just drag the concatenated list over here. And our system has one list to work with now. This is very important if you have, for example, feature lists of products in several data fields and several lists. If you want to put them together in one larger list and then, for example, do other fancy stuff with it, let's say putting an and in between the last 2 entries, like this: orange, violet, brown, pink, and gold. So for this enumeration to work correctly, you have to put it into one larger list. That's, for example, how you merge 2 lists. Of course, we can do a bit more fancy stuff with lists. We can filter lists, for example, like removing elements that we don't want. So, for example, we have a list in here. It's called list of numbers. This one. I will read this list just as we did before. List of numbers. It's a list. We have the preview 23, 2, 65, 23, 9. And I drag a mapping node next to it. And for example, let's say we want to remove everything that is smaller than 10. So again, I have to add my parameter connected to the data node. And now I can use a function which is called filter. Filter. This will also give you a bit of help. So items is the original list. And then there's something interesting. This is called func, short for function. In here, you can define a logical condition which must be met by every single element of the original list. And if it does not fulfill that condition, it will be removed from the list. So a filter. Let's try that. So param1 is the original list, comma, square brackets open, and it completes the closing square brackets on its own. Then I type a name for every single element, how it should be called in my condition. I will call this here EL, but it actually can be anything. It's a freely choosable name. Then I draw a little arrow with minus and larger than EL. And then I can formulate the condition. So hashtag EL, which stands in the condition for every single element larger than 10. Now compare the results. The 2 and the 9 are gone. 23 and 65 are still there. And that's how you filter unwanted elements out of a list. You access the original list and you define a filter function with a logical condition in it on which elements to keep. Okay, so again, add a group, add a variable at the end, connect it all up, call this filtered list, and we have the filtered list in here. Now we can sort elements of a list. Of course, if it's numbers, we can sort the elements of a list also. This is a bit easier, but equal to this one. So again, I want to sort the same list as in here, so I can reuse that. Just add a new mapping expression, new mapping node, sorry, connect it up, and then use the function sort. And I want to sort the list in param1. And now our system sorts it in an ascending order. We can also revert that. The function for that is called reverse. See, reverse items, close parentheses, and now it's descending. Huh? You also already see nesting in here. So I first sorted the list ascending, and then the result of this sorting is now my input for the reverse function, which is around that sort function. So put it in each put one function into another, like Matryoshka figures, like these small puppets, and then you can do more than one operation on your data in a mapping expression. Now, again, let's put a group and a variable in here so we can use it over in the right section. Sorted list. I can use it in here. Again, sorted list. Okay. And last but not least, we can, of course, do some arithmetics. Let's do that in here also. Same way to structure it as above. We have to read the number somehow that we want to calculate with. So number 1 is a number, and number 2 is also a number. You see we have 7 and 3. Now put a mapping node next to it. Add the 2 inputs. You always need as many inputs as you have input data streams. One data stream, another data stream, 2 inputs. And now we can do calculations in here. Again, just write param1, the arithmetic symbol, the operation for addition is a plus symbol, and the other data field. Param1 plus param2 equals 10. Now, you may have noticed right at the beginning, I added a plus between these 2 input parameters too, but these 2 are text. When we are dealing with text, a plus symbol means write them next to each other, concatenate them, join them. When we're dealing with numbers, a plus means an addition. Okay? So always notice what data types you are using your functions with. That's very important. Okay, again. addition result, and again, let's add variables to the input numbers. Number 1, number 2, and now we can add them again in here. So number 1, number 2, and the result. Okay, 7 plus 3 equals 10. And of course, when I switch the numbers out, 10 plus 2 equals 12. Okay, same thing. Let's do that for division. Of course, I can change, or of course, I can copy this whole structure in here and just switch out the calculation symbol, the operation. So I have a division and rename my result. This is, of course, a division result. So I can use it over here. First, second, and division result. So number 1, number 2, and division result. Okay, so 10 divided by 2 equals 5. 7 divided by 3 equals 2.3. The output limits this to 3 digits after the comma, but we can calculate, of course, in a higher precision. Okay, and the last thing we can do, we can of course do the same thing for a whole list of values. So for that, I also can just open a data node, or add a data node, access the list of numbers. I have 23, 2, 65, 23, 9. Add a mapping node, connect it, and add my function in here. So this time the function is sum of param1, which is 122 for this list. Also add a variable summed up list, and I can connect it in here. Yeah, sum of the list. Let's use the sorted list. Sum of the list is 122. So this is how you, in principle, build all of your data modifications with mapping nodes. Now, you may ask yourself, how can I find these functions that I can use in the mapping expression? Of course, we have a full documentation about these functions. You can find them in our documentation under reference, NLG Cloud reference, and then from data types over expressions until function library. So for example, in data types, you can see documentation about the data types you can work with. For example, a documentation about how lists work. You can find a documentation about simple expressions like the arithmetics I just showed you, like addition, subtraction, multiplication, and so on. And in the function library, you can find all these more complicated and more sophisticated functions that our mapping expressions support. So for example, we have sort here that I showed you in the documentation, and we have a small description for each function. And the really cool thing is you get this gray box in here, which you can always read the same. So in the upper gray bar, you have an hypothetical input data set, like 45321 is a list, which would be equal to what is input in param 1 in here. Yeah, the upper gray bar is this input port. Then you have the mapping expression on how you would write that, how you would access this. So the black part is what you type in here. And the lower gray part is the output that you can expect, which is the value that you would find here or in the preview section. And with that documentation, you can find all of the functions that we have. If you can't find a function that you need or don't know which function you would need to fulfill a certain expectation or requirement that you have in changing your data, please always come to us. We're very happy to help you find the correct function and also implement it so that it works correctly for you. So please remember to look up the docs.axsemantics.com. It's the address of our documentation, and you find all this information in there, all the functions. And yeah, these were the mapping expressions. I hope this webinar can help you a bit on creating more sophisticated content projects. And thank you for watching this, and bye-bye.